So we're going to solve the same systems you had last night, but the equations are going to be solved algebraically. Now, this is a reminder from yesterday. We talked about this yesterday. Consistent versus inconsistent. If you have anything in common between the two lines, the two equations, they're consistent. Either one point in common or infinite points in common, the system's consistent. But if nothing is in common, they're inconsistent. Do you know where these notes came from that I put right here? Yesterday, all I did was copy and paste them right into here. So, consistent versus inconsistent. Consistent means you have at least one point in common. Inconsistent means no points in common. If there's no points in common, what's the system look like?
Parallel.
Parallel. Two lines that are parallel. Now remember, everything we deal with is in a plane. So when we're graphing, if there's nothing in common, it's going to look like this. It's going to be parallel. The lines can't do this. Okay? These lines have no points in common. They are inconsistent also. We are not going to deal with those just yet. What do we call lines that look like this? They're what? Take the skew. That's all right. That's a good pull. I'm sure you didn't cover that very much in geometry. It was probably something they mentioned quickly. When you're in a space and your lines are not in the same plane and they don't cross, they're called skew lines. We're not going to deal with those. Our lines will be parallel, but they'll be in a plane. Remember, dependent, independent means one solution only, independent. Infinite solutions, dependent. Same line, different lines. But they have to be consistent. You can't be dependent or independent if you're inconsistent. That doesn't make any sense. Because you have to have a point in common. So that's consistent. Dependent is one point in common. Sorry, dependent is none in common. Independent, one solution in common. Right? Okay, these notes are from yesterday. I like algebra. Okay, I like teaching it. I like actually the process of doing it. I like it when you go to honors pre-calculus, you do even more in-depth algebra. It's like a puzzle to me. This graphic method for me just seems like so much work with so little reward. The first method you learned algebraically after graphing systems was called the substitution method. Again, the notes for this class are online. If you look the night before, you can have these things all ready and you don't have to spend this time right now copying down this process. What frustrates me is that some of you aren't going to copy it down and you won't be able to do this process. This is like, all you have to do is follow directions. The ladies do great with this. Guys and directions always maybe not the best thing. I don't need any directions. Throw that manual away. Substitution method is basically telling you you get to pick whichever equation you want and solve it for whichever variable you want. What I'm telling you here is if you always choose the variable that has a coefficient of 1 on it, if there is one, that's the easiest. If you don't have a choice of a coefficient of 1, you can pick the one that has a -1 if there's one of those. And after that, substitution method is a pain. You pick whichever variable you want. So when we look at this example, I have coefficients of 3, -1, 2, and 3. I'm going to choose to solve for y in the first equation because it has a coefficient of -1. It's the easiest to solve for. So if I take that first equation, 3x minus y equals 12, What do you do if you're going to solve it for y? What's the first thing you should do? Go ahead.
Subtract 3x.
Yeah, get the x on the other side. That's going to give you negative y equals negative 3x plus 12. So I'm almost at the point where I've solved for y. What do I do to solve for y now? Multiply both sides, or every term, by negative 1. This term, and this term. And that's going to give you y equals 3x minus 12. Or if you put negative 12 plus 3x, that's fine too. Getting all this? Uh-huh. Photographic memory, I want one of those. Anyone have one of those? I had a kid a few years back. Had one. All you had to do was look. It's like taking a picture. He remembered everything. He was a superstar. Yeah. And then he threw it all away first. His brother got in a fight with his dad. This kid was in this class as a freshman. A+, never missed a point. This next year, he was in honors, and his brother got in a fight with his dad. Dad threw the brother out, and he said, well, if you're going to be that way, I'm not going to do any more work in school. So he stopped getting perfect grades and got C's. And he was probably the most brilliant kid I ever had. What a waste. He could just look at everything, and it was literally like, I remember everything. It was amazing. Step number 1 is done. Step number 2. Once you have a y equals or an x equals, take whatever y is equal to and substitute the value of that variable, in this case y, into the other equation. So we go back to the beginning, we say, well, which equation did I solve? I solved the first one. I solved it for y. So what I want to do is I want to take the y. Oh, that's not good. All right, so we'll just circle it. We're going to take this y, and we're going to replace it with 3x minus 12. Every time you substitute, whatever you're substituting, put it in parentheses, just as a matter of fact, and you'll never screw up the distributing. When you don't put it in parentheses, you forget to distribute. So in the second equation, where the y is, I'm going to replace it with 3x minus 12. Because that's what y is equivalent to. 3x minus 12. When you distribute the 3, don't forget the 12 has to be multiplied by this 3 also. We're going here and here to get 2x plus 9x minus 36. We're solving for the remaining variable, which is going to be x. If you combine the x's, you get 11x. If you push the 36 on the other side, you get 110. And when you divide by 11, x is 10. You're almost done. Once you solve for that variable, plug the value of the variable you solved for in step 3, which was x equals 10, into either one of the original equations. So x equals 10, do you want to plug it into the first equation or the second equation? It doesn't matter. How do you know which one to pick? Whichever one looks easier. That's exactly right. Whichever one looks easier to you. Which one does it look easier to put a 2 in or 10 in for the x? Which one? The first one? Right? Some people will say the second one. Doesn't really matter. So we're taking this, and we're going to plug that x equals 10 either here or here. I don't care which one. Let's see which one I did. I did the first one. So 3 times 10 minus y is 12. 30 minus y is 12. And y ends up equaling 18. The solution to the system is 10 for x, 18 for y. 10, comma 18 is an ordered pair. Do not write down x equals 10 and y equals 18. I will take a point off and put ordered pair. Of course. So once you solve for the other variable, the y in this case, I always take my answer and check it in the other original equation. So I plugged into the first one, so I can take 10, 2 times 10 is 20, 3 times 18 is 54, 20 and 54 is 74. That's a good answer. So that checks. It only takes about 10 seconds to check. And one careless mistake will give you an answer, but it just won't check in that other equation. No? Everybody okay? Yeah. I just did that. You want me to do it again?
Well, you like flip back up to the top.
Substitution method. Every single person in this room has done this before. And you're not going to see anything new on substitution. How do you know, if you're given the choice, you got a system, how do you know it's going to say solve by any method you want? When do you graph it to solve that system? Okay, it doesn't. Here's a system, solve any method you want. When you're looking at the system, you go, oh yeah, I'm graphing this system. When should you do that? Okay, it says solve the system by any method you want. Here's the system. What about that system is the giveaway that you should be graphing? When should you graph it to solve the system? What? Never. Never. It takes too long. It's inaccurate. It's a royal pain in the butt. So unless you're a masochist, you shouldn't be picking graphic method. Let's ask the same question about substitution. When should we pick the substitution method?
When one of the coefficients is 1 negative.
Attaboy. It's in the notes. When one of the coefficients is a 1 or negative 1, by choice, you could use substitution. That would be the time when it would be best. Even better, if one of the equations looks like this, y equals or x equals, it's just screaming at you. Please use substitution. I'm all set up for you. There's no need for you to do anything else. Any questions on the example or the process before we look at another example?
Just hold all the way down.
Can I?
Well, just like here.
And folks, check your answers. It takes 10 seconds and it will allow you to catch yourself making the careless mistakes. It's really, really easy. Okay, so this is kind of the book version of substitution method. You're welcome to check that out. You can look at this. I'll give you this example first because it's already done. These are, what kind of a line is this? Please don't say straight. It's a vertical line. And no work to graph it, but it's a vertical line. And we already know what x is. In the solution to the system, it better be negative 2 comma something. Because if it's not, how could it possibly be a point on that line? It's like 3 points. So what do? I already know what x is. Plug it in for x and solve for y. Y is 3. The solution to the system, negative 2, 3. Easy. How about this one? What do? Plug 1 in. Plug a 4 in. Where do you see the y? And solve for x. x equals -7/3. It's not that pretty, hard to get that answer graphically, but the solution to the system is -7/3, comma, 4. What kind of a line is y equals 4? Horizontal.
When you check it, what equation do you put in?
Hard to check this. I would put them in. Just look at it. Is -7/3 4 on this line?
No, I know that, but I'm saying for, like, if you said the other.
Well, the other equation in this problem is this one.
Yeah.
Kind of hard to check. I mean, it's too obvious to check. Is it on that line? You bet. Does this check in here? You bet. In the first example that I gave you here, remember, we found x by using this equation right here. Oh, yeah. And we solved this equation for y. And then we substituted it into this equation. Okay? Here's the substitution right here. So when you get x equals 10, and you plug it into one of these two, doesn't matter which one, we plugged it into 3x minus y equals 12, you want to take the answer you get and plug it into the other equation, not 3x minus y equals 12. Technically, you should check them both. But because we all have our t-shirts on, what's this mean? Lazy. If I could get you to check one of the equations, check the one that you didn't use to get x equals 10. Okay? So when we plug the 10 in to get the y is equal to 18, we use that equation right here. Plug the 10 and the 18 into the other equation, and that will check as good as the lazy one is going to be. Right? Try solving this system by substitution. Fine. Take them off. Come out of here. 3x plus 4x plus 8 equals 1. If you had a 4 right here, what mistake did you make? Didn't distribute. That's this one. Remember that? Most commonly made mistake in algebra. A lot of people put a 4 right here. And then everything else falls apart. And you know what they don't do at the end of the problem? They don't check it, so they never figure it out. So here we're going to get 7x equals -7, and x equals -1. What do I do with that -1? Which equation?
2x plus 4.
The second one? Okay. So -2 times -1 plus y is equal to 4. 2 plus y is equal to 4. And y is going to be 2. So the solution to the system is -1, 2, as an ordered pair. I got this from the second equation, right? 3 times -1 is -3. 2 times 2 is 4. -3 plus 4 is 1. That's a good answer. Substitution method is easy as long as you have a coefficient of 1. When you don't have a coefficient of 1 and I force you to do substitution, you should be cursing me. All right? That's just being mean. Not nice. Okay? A third method, and you already again know this one, so nothing new. Third method is called the elimination method. You can put all the equations in standard form for the elimination method, but you do not have to worry about A being positive. It's perfectly fine for A to be negative in this process, but you are asking for it if you don't adhere to the integer part. A, B, and C need to be integers, otherwise it's just too hard to work with. Again, on the test, you have questions. And on tomorrow's quiz, you will have questions where it says, You must do substitution. You must do elimination. You must graph. But then you'll also have a question where it says, do it any method you want. When do we graph these if we have the choice? Never. You never want to graph them. When do we want to use substitution? One or negative one coefficient, and then elimination is for everybody else. Get yourself so that both equations are in standard form, and then choose whatever variable you're going to want to eliminate. It's up to you. Whichever variable you want to eliminate, you are then going to get opposite coefficients on that variable in the two equations. So one of your equations you might get it to be a negative 12x, and on the other one you want a positive 12x. You might get a negative 5y on one, positive 5y on the other. 24x, negative 24x. You need to have the opposite coefficients. Once you have opposite coefficients on the two equations, add those two equations. If you add things with opposite coefficients, what will happen?
They explode.
They do what? They cancel or?
Explode.
What's the name of this method? They eliminate. They're gone. Bless you. Bless you. Why is management smart? Of course I'm going to scroll back down. The patience thing here. Yeah. It's not part of the DNA in the women, I think. That's what I think. Come on, women, fight for yourselves. Stand up for yourselves. Tell me that you're really patient. Yeah, right. There'd be a big fat lie. You'd have to lie. Okay, so let's look at this example for the first three steps. Look, it's the same example. It's the same example we did before. We already know the answer to this. All right, we're just going to solve it by a different method. Do you think we could possibly get a different answer? No, not going to happen. I have x's, 3x and 2x. Coefficients are 3 and 2. What's the smallest number they both go into? 6. So I could multiply the first equation by 2 and the second one by negative 3. But when I look at the y's, I have a negative 1 and a positive 3. What's the smallest number 1 and 3 both going to? That means I only need to change one equation here if I get rid of the y's. So I'm going to multiply the equation A by 3. 3 times equation A, I'm going to call this new equation C. If you don't want to make this kind of notation, that's fine. This is just how I keep track of my work. So I multiply everybody here by 3. Don't forget the 12. That's the one we often trip up on. We get the 9x minus 3y, but then we put equals 12. You got to make sure it's all the way through both sides. Look at these two equations, B and C. The coefficients on the y, 3 and negative 3. Those are your opposite coefficients. What do you do with this equation B and C now that we have opposite coefficients? What do we do with the two equations with opposite coefficients?
Keep out the y.
How do we do that? No. Add the two equations together. Add the equations with opposite coefficients. So when we add B to C, 2x plus 9x, how much? 11x. 3y plus negative 3y, eliminated, gone. And 74 plus 36 is 110. So once you add these equations, one of your variables is going to disappear.
Can you scroll back up?
Of course.
So, if the top equation, if it wasn't negative y, if you have to multiply it
By negative 1.
3.
Oh, sorry, yeah, negative 3. My bad.
Okay.
Yep. And if I wanted, I could have done a 2 and a negative 3 here. Get 6 and negative 6 on the x's. Doesn't matter. It's whatever you see. Once we solve for that remaining variable, you're back to where we were with the elimination method. What's wrong? You said, oh my God. It's like a melodrama. Dude, patience, man. We're going to get there. When we solve, we divide by 11. Just like with substitution, we get x equals 10. X equals 10. What do I do with that? Hang on. Plug it into one of your original equations. Just like the rest of the steps are the same as elimination. All I did was copy it. Plug the value of the variable you solved for into one of the original equations. Solve for the other variable. Check. Okay? So 2 times 10 plus 3y is 74. Subtract the 20. We're going to get y is equal to 18. Okay? So there's the rest of the steps. There's nothing different than from substitution. They're identical. No, because I copied and pasted. The check or to get the other variable. Doesn't matter. So in this example, where, let's see, what did we solve? We solved for this x equals 10. You take it back to one of the 2 original equations. Don't use one of the ones you multiplied by. It has to be one of the 2 original. Doesn't matter which one.
So if you had to multiply both equations by a number, and then you were checking it,
Yep. You check into the original equation.
just the any one.
Either one. Well, look, we got x equals 10, right?
Yeah.
We're going to take this and put it into this equation. I think this is the second one. Okay? And then I solved for y. The solution, 1018, gets checked in the first equation. Don't use the equation that you got your last variable from. Plug it in the other one to make sure that it checks there. It's going to check, even if you screwed it up, it's going to check in the second equation. Does that make sense? Even if it's not the solution to the system, it will check in the second equation
Plug it into the one
that you didn't use last.
Okay.
No? Somebody else?
Just go back down to the bottom.
Of course.
Maybe a little up.
Yeah, a little bit.
Okay, these are the book notes. They're there for you to have that. We can do this example. I will always have my notes in the side where I letter A and B, and I tell you what I'm multiplying the equations by. Okay, and I tell you which equations I'm adding. You don't have to do that. Very few of my students over the years have done it, but it really indicates a total understanding of the process. Which variable should we get rid of? X. What should I do to the first equation? Nothing. What should I do to the second? 4. 4. So 4 times B is going to be C. Negative 8x plus 12y is equal to 13.
No, it's not. It's equal to
You did
52.
the last.
Oh,
70.
okay. Now, I can tell you from experience, believe me, don't believe me, I don't really care. But I can tell you from experience, if you try to add equation A and C right now, that sometimes you're going to do a great job, negative 8x plus 8x is 0, and sometimes you're going to do 12y plus 3y is 15y. By mistake. So for me, I know this is going to take 3 more seconds. I'm going to write the 2 equations next to each other instead of having this B equation in between. So that when I'm adding A and C, the x's cancel, it's 14y and 56. So what does y equal? 4. Nice, pretty cool. What do I do with that 4? Where?
Another
The
top equation.
Or
A, B.
use one word to tell me where it needs to be plugged into.
X. And Y.
Look at your notes. Once you solve for the variable, plug the value of that variable into one of, no, you're down here on step 5, 6, or 7, or 8. I'm back up at like step 3 or 4. Plug in the value of that variable into one of the original equations. It doesn't matter which one. Either of these two will be fine. Which one do you want to use? The top one? That's fine. 8x plus 2 times 4 equals 4. 8x plus 8 is equal to 4. 8x equals negative 4. So x is equal to negative 1/2. That means the solution to the system appears to be negative 1/2, 4. Where should I check that answer? The second equation. I use the first one to get x. Check it in the second one. Negative 2 times negative 1/2, how much is that? Negative 1? Positive 1. And 4 times 3 is 12. 1 plus 12 is in fact 13. Okay. Any questions on that example? Need some toothpicks? Yeah. If we put one here and one there, it might help keep those open. Just an idea. All right, let's try C. C, you got to concentrate all the way through. The careless mistakes blow these up big time, and you get these nasty fractions. Let me tell you right now, do not give me an answer as a decimal. If your answer is a decimal, 99 out of 100 times you're doing it wrong. Okay? So if we take, I'm going to call C and D, we're going to multiply C by what? 3? Well, if you want to get the y's, you'd use 3. So you'd have 9x minus 12y equals 117? 11. Yeah, it probably is. My math skills not very impressive. And then we're going to multiply d by 4. So you're going to get negative 20x plus 12y is equal to 56. Now, why did I choose to multiply by 3 and 4? What's the honest-to-God reason why I chose to multiply the first equation by 3?
Someone told you.
Because what? Somebody said it.
Someone told you.
Somebody told me. The first person, whoever it was, said multiply by 3. They wanted to get rid of the y's. Now, a couple other people were like, whoa, whoa, I want to do the x's. Let's do 5. That's how I did it. Too late. You got to be quick. We're going to add e and f together. You're going to get negative 11x. The y's are toast. And when you add these, what did you get? If you divide by negative 11, x equals 5. What do you do with that 5? Which one? The top one, okay. 3 times 5 minus 4 times y equals negative 37. 15 minus 4y. If you subtract the 15, be careful now, negative 37 minus 15, how much is that? 2. So y is going to equal 13. The solution to the system is 513. Now, we use the top equation to get the 513. We check it here. 5 times negative 5 is negative 25. 3 times 13 is 39. 39 minus 25 is 14. That's a good answer. Okay? You need to leave room on your paper to do a great job on this. We're not going to smush it all into 3 lines. Okay? Now I want to show you an example of the special circumstances. Okay? And we're going to do substitution here. This is A, this is B. What do you want to multiply by?
3.
Negative 3 times A gives you...
Are we doing elimination?
No, I'm doing elimination. Where does it say use substitution? When did I say that? Yeah, but I can't go back. Once I hit stop, that's the end of it. You don't have that luxury. This isn't TiVo. I meant, sorry, the microphone's back there. I meant elimination. Really, I mean, we're just going to solve it any way we want, and I'm choosing elimination, if that's okay. The women here, I feel like they're going to take rocks out when I make a mistake. I can't make any more mistakes. Look, I'm sweating. I'm afraid now. I'm going to use elimination. Negative 3 times A, negative 3x plus 6y, negative 12. So when we add these two equations, B and C, what happens? So the x's cancel, the y's cancel. So what do we really have on the left? 0. On the right, however, what do we have? Negative 4. Now, I want you to think about this. When is this true?
Never.
Be careful. When is 0 equal to negative 4?
Never.
Never. No matter what. There's no situation where this can be true. This is called a categorically false statement. If you get something that is always false, the system has no solution. That's a special situation. So there's no solution to that kind of a system. So whether you're doing this by substitution, if you choose, or elimination, if you choose, either way, you get something that's totally false, no solution to the system. Does that make sense to everybody? Yeah.
Just write no solution, and you put line from the equal sign.
No solution to the system. This thing right here,
No, like 0 equals negative 4, and put a line from the equal sign.
well, that just tells you that 0 is not equal to negative 4. I would write I agree with you, but that doesn't, the directions are to solve this system. What this means is that, what does this mean if there's no solution? So, but what does it mean for us in terms of this system? Huh? No, it's definitely a system. Truly. What do you know about this system? And don't tell me there's no solution. I do know that. What is it? They're parallel, which means that you have an inconsistent situation. But the answer has to be no solution. Okay? You have parallel lines when you get something like this. There's no solution to the system. Okay? We don't want to really graph those. That's what would happen if you did. Now the other situation with this pretty, not so easy. What are you going to multiply this equation by? Let's say we want to get rid of the x's. I know, this is so hard. What's the smallest number 4 and 14 both go into? 28. If worse comes to worse, and you're really oh boying it, multiply 14 here and 4 here. You got a calculator, it's easy. But we could do 28, so we do 7 times a, 28x minus 70y is equal to 56. What would you multiply the b equation by? 2. And you're going to get negative 28x, positive 70y, and negative 56. Watch what happens when we add these. C plus d. What do we get here? 0 plus 0 equals 0. How about that statement?
Always true.
Always true, which means what?
Infinite line.
Same line, infinite solutions to the system. These are the same lines if you were to graph them.
No, 15.
You gonna make it? Yeah. There you go. It's like you're running out of gas. Like a remote control person. Alright, so here is what I want you to do.